In today's lesson 10.5, angles related to a circle, we will again be exploring some definitions and quite a few theorems. The first ones we're going to look at are inscribed angle and tangent chord angle. We actually have talked about inscribed angles previously. The new one is tangent chord angle. A tangent chord angle is just as its name suggests. It's made up of a chord and an angle, as you can see in this diagram right here. So this angle formed of the tangent line and the chord. Now, the theorem that goes along with this is the measure of an inscribed angle or tangent chord angle is half the measure of its intercepted arc. So meaning, if this arc right here was 70 degrees, then the tangent chord angle would be 35 degrees. Now, that kind of relates to what we talked about before with inscribed angles. If I have an inscribed angle here and here that intercepts that same arc of 70 degrees, we know from previous lessons that that angle will be 35 degrees. The next definition is a chord-chord angle, and again, like its name suggests, it's composed between two chord angles. So when they intercept, you'll see that they form four angles. Now let's suppose we have these two chords that form different angles, and we know that the arc of AD is 200, and the arc of BC is 60. And we need to figure out what theta and what x equals. Well, to find what theta equals, you basically just take the measurements of the arcs and average them. So we'll take measurement of AD and measurement of BC divided by 2, which is 200 plus 60, divided by 2, which happens to be 130 degrees. So theta right here will be 130 degrees. And x, since x is supplementary, angle x would be 50 degrees. Now, you could also find the corresponding angles because they're vertical angles. So this angle would be congruent to x, while this angle would be congruent to theta. And finally, we're going to look at three more different types of angles before we get into some examples. The first is a secant-secant angle, the next is a tangent-secant angle, and the last one is a tangent-tangent angle. Now, this should make sense because if we look at this line and this line, they are both secant angles. So this is a secant-secant angle. And again, this one's composed of a tangent and a secant. So this is tangent-secant. And then this last one is tangent-tangent. Now, to find any one of these angles formed by the secants and the tangent lines, all you have to do is basically take the averages of the angles. You'll take the difference, not the average, you'll take the difference between the two and then divide by 2. So in this first case, the secant, what you're going to do is you're going to take this outside angle and you'll subtract it from the inside. So you'll take it 80 minus 20, divide that by 2, and then this angle up here would be 30 degrees. That would be that angle formed by both the secant lines. You do the same thing with tangent secant. You're going to take the difference between the two angles that are kind of formed by the two lines. So you're going to take this outside angle, which is CA, and you'll subtract it with 60 degrees. The measurement of angle BC, so 160 minus 60 divided by 2, and that gives you 50 degrees. So that will be the angle formed by those two lines. And finally, tangent-tangent is no different. You're going to take the outside angle formed by the 2 points, and it will be subtracted by this inside angle. Now, you'll probably look at this and say, well, they don't give you that outside angle. Well, you know that the total measurement of a circle is 360. So if this part right here is 160, then that means that this angle right here has to be 200. So what you can then do is you'll take that outside angle, 200, subtract it by the inside of those points, 160, divide by 2, and you get 20 degrees. And that will give you that measurement formed by the tangent lines. And that's kind of what Theorem 88 says. The measure of a secant, tangent, or secant, tangent angle is half the distance of the measure of the intercepted arcs. Alright, let's take a look at this example. We're given the following diagram, circle O. We know that A, B, and AC are tangent segments. DC is a diameter. Angle, or the measurement of arc BC is 100, and the arc of EF is 60 degrees. Angle DOE is 70 degrees. And we need to find out lots of different kind of measurements within this diagram. Let's start with the first one. We have angle 1. Angle 1 is right here, and it's also up there, and you'll notice that's formed by AB and AC, which are both tangent segments. Now, we'll be able to find that angle by using the tangent-tangent formula, which subtracts the outside arc from the inside and dividing it by 2. So the measurement of angle 1 can be calculated by taking 260 minus 100 and dividing it by 2. Again, because this is 100, that outside arc has to be 260. So then we get 160 divided by 2, which will be 80 degrees. So measurement of angle 1 will be 80 degrees. Now let's go to some other ones that will be fairly easy to figure out. If this angle right here is 70 degrees, that means that DE will also have to be 70 degrees. And since DC is a straight line, it's the diameter, and it cuts into a semicircle, we'll take 170 and 60, subtract it from 180, and you're left with 50 degrees for the measurement of CF. So now, if CF is 50 degrees, we also know that BD is 80 degrees, because if we add up all the sums on the outside, they need to equal 360. So 100 plus 50 plus 60 plus 70, subtract that from 360, we're left with 80. So BD is 80 degrees. So then let's look at angle 7. That's a chord angle. So to figure out a chord angle, you're going to take the sum of the outside and divide by 2, and that gives you 65 degrees. Now let's look at angle 6. Angle 6 is right here, and because AB is a tangent line to the radius BO, what you'll notice, or remember hopefully, is that a tangent line is perpendicular to the radii, which means that angle 6 will be 90 degrees. The same can be said with ACO, that is 90 degrees. Now, since this angle and this angle form a straight line, that means that angle OC, and then we'll call that X maybe out there, is also 90 degrees, which happens to be angle 3. So angle 3 is considered 90 degrees. Now let's look at angle 2 right now. Angle 2 is right here, and you'll notice that it's right from the center of the circle, and its lines are formed like this, which you'll see that it forms the arc BD. And we already found out that BD was 80 degrees. So that angle too will be the same, 80 degrees. And finally we have angles 4 and 5. You'll notice that 4 and 5 are formed by a chord, but they're also formed by two radii. And what you'll notice about two radii, I hope really you remember, is that the radii are congruent. So if those are congruent, that means that those angles are congruent. This angle being 70, that means that the sum of these two angles has to be 110. And if we divide that by 2, each of those angles will be 55 degrees. And finally, our last problem. Given the following diagram and that WZ is congruent to XY, and that arc WXY has a measurement of 200 degrees, we want to find out what angle P is. So let's mark accordingly. We're given that WZ is congruent to XY. And we're also given that WXY is 200 degrees. Now, since these lines right here, and they're kind of chords of the circle, as long as being secant lines, since those are congruent, that tells you that the arcs are going to be congruent. And since those arcs are congruent and they share the same segment, we can also say that XWZ is also 200 degrees. Now let's go back to what we need to find. We know that if we are to calculate P, we need to subtract this arc by this arc. So let's label those A and B. So angle P can be found by A minus B divided by 2. If this right here is A, then that makes this segment, or this part of the arc, 200 minus A. And this part, WZ, the same thing, 200 minus A. And that gives us the entire circle. So that also tells us that A plus 200 minus A plus B plus 200 minus A equals 360. If we solve that, you'll get 400 plus B minus A equals 360. Which ends up getting us B minus A equals negative 40. And if we change that around, that's really negative A plus B equals negative 40. And if we divide by negative 1, we get A minus B equals 40, which you'll notice is that up there. So we'll substitute that in, 40 divided by 2, which is 20. So the measurement of angle P is now 20 degrees.